It is believed that 30% of students who do maths get an A star, and a teacher wishes to test this claim at the 5% significance level. Find the critical regions. So let's set up the hypothesis test because we're going to do the test at some point later. So we're going to have H0, P equals 0.3, and H1, P does not equal, so we're testing this claim, 0.3. And we're going to say P is the proportion of students who get an A star at Maths A level. We've got a distribution here of 30 students, assuming the null hypothesis is true. And we want the critical regions. So that's going to be two regions because we've got a two-tailed test. And one region is going to be x is less than or equal to some number such that this is less than 0.025. And this is half the significance level because the other half of the significance level is going to be this part, the other half greater than or equal to some number to be less than 0.025. And our calculator doesn't give us this, so what we want is less than or equal to some other number to be greater than 0.975, and that's going to convert to this second line here. And the way I'm going to do that is I'm going to use binomial CD, and I'm going to use the list function or list option. So that's going to allow me to put in multiple values at the same time, and that's going to be helpful for me because I don't know what the number I want is, so I'm going to test quite a few different ones somewhere in the region where I might expect it to be. So if I put in a few numbers, I find that the last number for which this is true is 3. So when it's 4, it's 0.03, which is bigger than this. So px less than or equal to 3 is 9.3 times 10 to the negative 3. And I see that in part C, I'm going to need to find the actual significance level. So I'm going to store that to the letter A in my calculator because I'm going to need it later. Then if I do the same thing for the upper tail, I find that the first number for which this is true is px less than or equal to 14. And that means that my critical region is x greater than or equal to 50. So my upper tail is going to be x greater than or equal to 50, and my lower tail is x less than or equal to 3. And again, I'm going to actually store this number. So this one has a probability of 0.983. I'm going to store this one to the letter B because I'm going to need to use it later. So let's store that. And now that we found the critical regions, we can find, say, well, 26 students failed to achieve an A star. So that means 4 did get an A star. So 4 is in acceptance region. So if it's in the acceptance region, we're going to reject H1, and we're going to say there is sufficient evidence to believe the claim that 30% of students who do maths get an A star. So that's part B, and part C is what's the actual significance level of the test. So the actual significance level is just the probability of the two critical values added together. So that's one of the probabilities, A, and the other one is 1 minus B, because the critical region is greater than or equal to 15. So this is less than or equal to 14, so I want to do 1 minus B, and I want to add A to that. And that's going to give me an actual significance level of 0.0263.